Welcome to Geometry Unit 6 video for skill number 45. I can prove, apply, and use theorems about properties of kites and trapezoids to solve problems. We will begin our notes on page 45A. The first quadrilateral we're learning about today is called a kite. And the properties of a kite, there are three. A kite has exactly two pairs of congruent consecutive sides. So this side is consecutive with this side, and that makes them congruent, and then this side is congruent with that side, which makes it congruent as well. Technically, for the kite to actually be a kite, we cannot have four congruent sides. We have to have only two pairs, so that's why we say exactly two pairs of congruent sides. The next property we learn about kites is that they have perpendicular diagonals. That means if we run the diagonal across the kite, they are at 90-degree angles with one another. So the kite here has four 90-degree angles there. Finally, the last thing that we know about a kite is that it has exactly one pair of congruent opposite angles. What that means is if we take this angle, it is congruent to this angle, and it is that pair. We do not have any congruency between this angle and this angle. So, kites, to review, kites cannot have four congruent sides, as that would make it a rhombus or a square. The diagonals intersect at perpendicular lines to one another, and it has one pair of congruent angles, and that angle is trapped between the two different side lengths. A trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel. This means that this side is parallel to this side. Some vocab words regarding trapezoids. The two parallel sides, AD and BC, those are called the bases of the trapezoid. And then the other two sides are called the legs of the trapezoid. And most trapezoids are not special. There's not a lot of other properties to them unless they are an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with congruent legs. Down here I've written down the three properties of isosceles trapezoids that make them special. The first being that they're special because the legs are congruent. The second property is that it has two congruent base angle pairs. So angle A and angle D are congruent on an isosceles trapezoid. Likewise, angle B and angle C are congruent. And then the last property of the isosceles trapezoid is that the diagonals are congruent. Finally, on page 45C, we discuss the trapezoid midsegment theorem. The midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the base lengths. This is similar to the midsegment of a triangle, except now we have the midsegment of a trapezoid. You could say that the length xy is the average of AD and BC. I've shown the formula for it, but basically you take the length of BC and you add it to the length AD, and then you split that in half. So it's the average of those two lengths. Example 1 shows a case where we're trying to find the value of x using the trapezoid midsegment theorem. So we can say that PQ is the average of BC and AD. So PQ is equal to half of BC plus AD, and we substitute the values. PQ is 20, and that is equal to 1/2 of BC plus AD, so 3x plus 28. And then I solve this equation for x. The first step I took was I multiplied both sides by 2 to get rid of the fraction. Then I subtracted 28 from both sides, and then finally I divided by 3. So I got a length or a value of x for 4. So in my trapezoid, the top length is 3 times 4, which is equal to 12. The midsegment is 20, and the base is 28. And if you notice, what we've done is from 12 to 20 we've added 8, and then from 20 to 28 we added 8 again. So there is that pattern that you can look for when solving problems like this. Using that pattern on this diagram, we can say 17 to 10 we subtracted 7, and so from 10 to x we'll subtract 7 again, and we get x is equal to 3. The keywords and ideas for skill number 45 are kite. So a kite is a quadrilateral with 2 pairs of congruent consecutive sides. A trapezoid is a quadrilateral with 1 pair of parallel sides, and those are called the bases of the trapezoid. An isosceles trapezoid would be a trapezoid that has the legs of equal length, and the trapezoid midsegment theorem, which states that the midsegment length is the average of the 2 bases of the trapezoid.